All right, we are going to be looking at some more examples of using calculus to evaluate and analyze particle motion. Example 3, a car moving with initial velocity of 5 miles per hour accelerates at the rate of a of t equals 2.4 t meters per hour per second for 8 seconds. How fast is the car going when the 8 seconds are up? So if we look at this, how fast would be velocity? All right, so what we want to do is figure out, if we want to know how fast is the car going when the 8 seconds are up, we first of all know the car was going 5. So if I'm going to put the velocity, so it was going 5, and then we're going to add how much the velocity changed. Did it go up? Did it go down? What happened? So to figure out the change in velocity, we're going to take the integral of acceleration. So the integral of acceleration from those first 8 seconds, so 0 to 8. So we're going to get 5 plus the integral from 0 to 8 of 2.4 t dt. And then from here, I'm going to use math 9 to calculate that. When I do that, I get 76.8. So basically what that means is the car the change in velocity is 76.8. So since it was already going 5 and now it's going 76.8 more, after 8 seconds it is now going 81.8 miles per hour. And basically what happened, if I was miles per hour per second and I took the integral, the per second dropped out. So now I'm just at miles per hour. Okay, part B, how far did the car travel during those 8 seconds? How far did the car travel talks about distance, and to get a distance traveled, we know that distance traveled is the absolute value from A to B of, the integral from A to B of the absolute value of velocity. So we are going to get that distance. We're going to go from 0 to 8 of the absolute value of velocity. And I don't have a velocity formula. However, I know to get from acceleration to velocity, we're going to take the integral. So it's going to be the integral of 2.4 t. So it's going to be 1/2 times 2.4 t squared. And that will give me 1.2 t squared. And so now I'm just going to use math 9 on my calculator to get that. And when I do that, I'm going to get 204.8. And figuring out my units, velocity is measured in miles per hour. So if I go backwards, the per hour drops out. So I'm just at miles. That's how far the car traveled. Okay, example 4. The graph of the velocity of a particle moving on the x-axis is given. The particle starts at x equals 2 when t equals 0. So that's going to be key when we're moving here. Find where the particle is at the end of the trip. Okay, so what we're going to do is first of all figure out how far did the particle move. So I'm going to figure out if this is a velocity curve. To figure out how far, what the change in position is, we're going to take the integral of it, or the area under the curve. So to get where the particle is at the end of the trip, I'm going to call this A, B, and C. So A, the area would be 1/2 times the base times the height. So that area is going to be 3. For part B, that area is going to be 1/2. It's a trapezoid. 1/2 times the height. The height of that trapezoid is 3. The sum of the bases would be 1, 2, 3 plus 2 to 7 is 5. That is going to give me 8 times 3 is 24. That's going to give me 12. However, this is below the x-axis, so we're going to have to give it a negative. And then C, it's another triangle. We're going to get 1/2 times the base, which is 3, times the height, which is also 3. That's going to give me 4.5. So to figure out where it's at, it would be 3 minus 12 plus 4.5. And the total displacement on that would be, let's see, negative 9 plus 4.5 would be 4.5, and that will be negative because more was below the x-axis than above. But we started at 2, so to figure out where the particle is at the end of the trip, it's going to be 2 minus 4.5. So 2 minus 4.5 would be negative 2.5. So the particle would be at x equals negative 2.5 at the end of that trip. So it moved further to the left than it did to the right. Okay, to find the total distance traveled by the particle, if you can recall, it's just going to go from 0 to, looks like 10 seconds on that chart, 0 to 10 seconds of the absolute value of velocity. Well, we just found the velocity by adding all of these together, but since it's the absolute value, what we are going to do on this one is anything that was negative, we are going to make positive. So this will be 3 plus 12 plus 4.5, because we don't care whether it moved left or right. We just care that it moved. So the total distance that it traveled, 3 plus 12 plus 4.5 would be 19.5. So that's how far the particle traveled. So hopefully now you are even more familiar with linear motion.